This is a signal generator. It's connected to an oscilloscope. I'm going to change the frequency, and something awesome should happen. As I increase the frequency, look, a sine wave starts to appear. Wow, that's cool. Increase the frequency even more, and more. It's at 4,000 hertz now. 5,000, 6,000, 7,000 wave peaks past a point per second. 9,000. Now it's increasing 1,000 hertz per click. 7,000, 8,000, 9,000, 10,000. Now I'm going to change the amplitude. Amplitude is the height of the wave from the center. See, the voltage changes the amplitude. Now I'm going to show different types of waves. Let's say there's square, pulse, triangular, partial sine. There's the CMOS, DC wave, half wave, full wave, positive ladder, negative ladder, noise, exponential rise, exponential decay, multitone, sync, Lorentz, and some interesting waves on here. And this oscilloscope picking up the different frequencies, amplitudes, duty cycles, and the different waveforms. That's pretty cool. Let's changing up the frequency again. Let's change it a little bit at a time, and you can start seeing the sine wave appear again. That's neat. I guess every instant pretty much it's putting a dot where the y-axis is voltage and the x-axis is time. The next fraction of a second it's putting another dot, and so on, and you pile those dots and connect the dots, and then you have waves, it looks like, and they go really fast. 50,000 hertz. That's 50,000 wave peaks per second going past a single point. That's pretty fast. Thanks for watching. If you enjoyed the video, click like and subscribe. Yay for science. Woohoo!